So yeah. Oh, resource to sources, volunteer to gather that. It's super easy. Like you just depending of what you use. Well, like I prefer mapping around my neighborhoods or where I live because it's easier for me or when I'm traveling. But you can also like on for student, I follow a bot that's called Small Town America, Small Town USA. I think I'm not sure. And then the bot is posting regularly like city where like it matched the numbers of people or household versus the number of building and the number of road. Then you can basically say like, oh, I have less, like let's say like you have 100 people and then you have no building. So it's make no sense. So the bot link to and then you can add building or correct the road. I like the learn OSM, but like if you are on Android, depending like you have like two like basically if you're on Android, like Street Compete is very good. Like let me find it. OSM Street Compete.
Yeah, I live in a slightly small city that information on OpenStreetMap is pretty sparse.
Yeah.
I imagine my coworkers and I could fill that in fairly easily.
Yeah, like I'm doing it slowly. Like I'm not like, super into completing everything. It's just like, oh, I'm here. Like, oh, this town have a nice deli, and the deli is not like referenced. I'm gonna add it. So just to add a bit more addresses, bike paths, and stuff like that. So, yeah, but I'm not like I count as a casual mappers, but like it's important because like I use also a lot of OpenStreetMap datas. And yeah, it's night and day, like the quality from like both continents. I don't know why. So if you're on Android, this Control V. Oh, I'm in Mac. So I hate Mac. Come on, how does it work? It's Command C, Command V, no? Command C. Where is it? Zoom here. Command V. No, not here. Where's Zoom? Here. Chats. So I definitely recommend if you are a beginner, like you use Street Complete. It's like a gamification version of it. So it's propose you challenge like around you. So like you download the I think it's only on and if you are on iOS, I use Go Map. It's it's definitely more harder than if you want a full mapping device on iOS, on Android, it's called Vespucci, I think.
Awesome. Thank you.
Both have super and GoMap it's a full-fledged and Vespucci, both of them are full-fledged like map editors, like they're like but for mobiles, mobile device. If I'm not on mobile device, I learned to use Java for OSM, but I do not recommend it as a beginner. You should start with the basic like ID editors. And yeah, like I am what I'm doing is like, I'm interested into like adding like, let's say bike paths or bike infrastructures. Then I just read the wiki, the OpenStreetMap wiki with the specific tag. And then I set up GoMap so I can just, add them. You have like it record like the last option you have selected, so it's way faster when I'm with the family. I'm not gonna say like, okay, I need to take 10 minutes to check the wiki. And so yeah, I recommend the Street Complete for beginners. This is great. Awesome. And they will ask you like yeah, a lot of information for biking and stuff like that.
Yeah, that's very much the application we need, is to redraw the bike paths around here.
Yeah,
or at least record them.
Yeah. And then like and if you're like doing in armchair, like definitely like just ID has become very good. Like the OpenStreetMap editors, I think it's Microsoft that's basically like found them. I mean, it's maintaining it, and it's super good. But I definitely like the GOSM, like the open source one, but it's way harder to understand it. It's definitely like you need the Java compilers, which obviously there's just one, but that still complicate a bit. And yeah, you need Java install and stuff like that. So anyway, but yeah, it's OSM, like, yeah. Especially if you live like in some place which is badly mapped, it's super easy to add stuff. Yeah. And then you can use like R to analyze the data, which is like you have two plugins for that. Two package, sorry. But yeah, I think it will be just 3 of us because Memorial Day. Do some people are saying something on the... Let me check also like the volunteer to present. Dang, what's happened with this Mac? I hate it. Volunteer to present. Control click. I'm at that point that I'm gonna install eMac on the Mac, so I have Dired to manage my computers. Also, we have no one today.
No.
Dang. Why is it red? It's nice. No, we have colors, but I should have checked it earlier. So,
And I wasn't sure if anybody was actually interested in the current chapter, chapter 11. Is the textbook all of a sudden telling you, hey, programming is a good idea?
yeah, it's basically that. But like, should we review it quickly or should we?
It's not long. We
Yeah,
could
we can review it.
probably just roll through the text.
Yeah, let's
Yeah.
go. I will not forget to do the start for Jim this time. And then I will like maybe share the book if I manage to geocomputation with R. And review it quickly. Like, should I share it? Yeah,
okay.
but it's basically that. I agree with you. Like, I will. I don't know. What's your? I'm curious. Like of what of your, like yeah. Do some of you like we can start by that, like I will say, like, do you write scripts with arguments or do you just run them? Like you can do that with R, like you know, you can as you do like with shell or with C, you can do argv something. It's not exactly argv, but name a variable, then define it, and just like do like R script, the name of your script, then the argument behind it, and run it. I'm curious, like, what's your workflow with R? Do you just like run RStudio and just like run the scripts? Do you use target? They mentioned targets. Do you use other kind of, like, for example, make other kind of like this is like just like, because yeah, what's the chapter is all about that. Like, obviously you should use function and stuff like that, but yeah.
For me,
I assume
I
every
haven't-
one of you are using function, no?
Yeah.
Absolutely. I think what you've posed is a good question. Personally, in my work, my work, I do tend to work towards functions and what would look like a package, what would build as something that has documentation and goes to Git and presents itself as an internal package. That's my goal. And the addition of targets, I think, is a fantastic discipline. So I'm fully supportive. Now, I understand that a typical BI analyst is not comfortable there. But this group goes that extra, that extra step, whether it's building and test or at least documentation, to have a package that someone else can install. And I think that's part of the magic here. So personally, my definition of done includes functions, it includes documentation, and it includes a build, and it includes the tests.
Yeah. Well, test is definitely something that I have to improve, especially because most of the time I feel I'm working on pipeline most of the time, where like, it's the inputs will change a lot of the time. I don't know. I work with a lot of government data, and they kind of change the way they structure the data all the time. For good or bad reason, I don't know. I'm not into like their I don't know. We should have more discussion, I feel, but yeah. So yeah, I agree with you. At my work, we use like at least 4 internal package to help the analysts. And I'm just and they were already built by the previous data engineer, so I'm just maintaining them. And just a function that connect to the database, it's just a tremendously helpful for so any kind of business analyst or geospatial analyst, like just wrapping around a good way to storing credential, loading the credential, and then accessing the data, having just a small print of remember to disconnect from the database. All of that take times, and all of that is a good, I feel is a good internal package that will still save like, yeah, on the analyst side, hour of work, and on the people, because like at least when I'm requested for help is when something is not working. And when something is not working, and the first step, like you have to check the connection, and if the connection, like if you have like opening a connection with Postgre or whatever you are using, it's usually just, it can be done in few lines of code. But if you had all these few lines of code, and if they were function, like definitely you jump right into what's it's difficult. So yeah, I definitely recommend the use of function even for like tasks like that, I feel. On the pipeline, I have tried Target on the pipeline side. I have 2 pipelines that run Targets. I'm not sure if I'm using it correctly. I like it, but I'm like I don't know. I will need to, I think, check what others are doing with it before being confident with it. I see. I like it. I like the way that it self-document itself, that it's enforced also the use of function to take something, test something, and bring it. But yeah, and to find finally, like on the tests, I think tests is difficult in a data environment that's managed outside of like opening connection, doing stuff like that. I think it's difficult with data that change a lot, because in data you kind of don't want to test it. You need to validate if it's meets some criteria. So I have seen people discussing point blank or point something. I don't know if you have read about it. I have not tested it. You have also validate. Maybe I can find resident. So yes, my but yeah, most of the time I think my coworker use script and do not use argument with script, or just change like an argument, like let's say like they have variable at the top of the script, and they will adjust this variable and then they will run the script. That's maybe contain function, but yeah, that's how we work. I don't know, what about you, Derek? Like
no, I usually do simple data analyses for my colleagues, the teachers who are looking at some classroom data, and it's enough to make some functions. If we have approaching a problem in multiple different ways, I might try to make some slightly more abstract functions that could just graph anything. But I haven't had a need to look into targets, or on the data side, we haven't had big enough data sets to look into error or even data table.
Yeah. Yeah, I think like one of the benefit of target is like it saved, it cached a lot of operation. So on the analyst side, it's like I would like them to do it because like, if you have big script and it's running and some function are taking time, and some of the stuff you are not changing it will catch it. So it just read it. It will not need to reproduce it. And also it enforces the use of function, which is very good because it's easier to debug. Like, if you are debugging a function, it's way easier. Like I have like at my work, like legacy code that's 600 lines of just a bunch of if else, try not, or and at best, like sometimes also what I have is like a YALM file. So, it's reading a YALM file that's contain like supposedly the name of the column or the outputs that will be right. And YALM can be very tricky because it has a hierarchy and they are piping into the YALM is like linking to the hierarchy and it become a mess. So I don't know if it's a good practice. I like it like because it's kind of a configuration file, but then on the debug, when you need to debug that, it's become very hard. So I don't know, but target, yeah, my take on target is like I would like business analysts to use it more. I don't know if they want that because they have different I feel they have different time. They need to do their work in, let's say, 2 weeks. 2 weeks is at best. The most of the time is 3 days, 1 week, and then they produce something. But if they implement a pipeline, if they use target for their work, they will, I think they will not be able to manage it just for like the implementation. But yeah, I don't know if you have used it or try it, but yeah. Yeah, no, the chapter is like, dry case. Every like big principle that sounds right, but are not easy to implement, I feel, at least for me. Yeah. And more I work also as a data engineer, more I use shell, just basic Linux whatever's, and the simple the better, because I'm sure like whatever the virtual machine is running somewhere, it has it. And so like I'm curious, like a lot of people are mentioning make. For me, make is like 200 pages of read before understanding something. I can use it, but like, I'm not like proficient with it. I don't know if you know. And I would like you, and that's why like I was asking the question, like, because you can use R, like have a script with arguments that you can pipe into it. Pipe by the sense of a shell script. You can like definitely define instead that you are using SQL, then sending to shell, then producing a graphic that's maybe, then you need like, I don't know. I have one software engineer in my team that's produced like a lot of dashboarding and reports. And he use and basically his workflow is basically like all the time is like producing, he use R Markdown and a lot of ggplot to produce like PDF reports. And yes, and he definitely like could improve like his workflow with like just that, I think. Even if the part like the IR ecosystem is super easy to do reporting, I feel. Like, it's just like you can just use Markdown, Kniter, you don't, and ggplot, this is all you need, I feel. And it's simplify Pandoc and simplify everything like you don't want to deal with. But yeah, that's my take on it. But yeah, so yeah, I would like, programming is good, but at what points do we gain as using R as most like C or that's at least communicate with other languages? I'm at that point at least in my work where I'm thinking more about it, because yeah. But still, using scripts is a huge improvement, And yeah.
Yeah, absolutely.
But yeah, go ahead.
I had seen with IoT data in Databricks and Spark,
Yeah,
Scala, that even in Spark SQL, there are ways to present your metrics in a nice batch, daily batch, from which a number of BI tools or R scripts could be run. And so orchestrating off of even one of those tools is pretty nice. It's pretty slick. In that case, no targets is required, but yeah, in a research environment or in an environment where you're enriching the data with other means of collection, yeah, targets has its place, definitely.
yeah, because it considers like the data source as an object.
Absolutely. Yeah.
And and so you have the connection between the data source as something that you represent as an object and the function on top of it.
Absolutely. Or pins, for example, if you've got dimensions, that don't change very often, then pins has a place. And I think the use of these tools is something that, well, and DevOps generally is something that we should focus on.
Yeah, as someone that's lived the research part of it, it's difficult to bring researchers to that do not understand necessarily. Like, I feel like, I don't know, you are in research also, no, Derek, no? You work for like a university, no?
Yeah, university, and just a little bit of research here and there.
Yeah, I imagine. But yeah, a lot of time, like, in research, like what's the end goal is like a publication.
Mm-hmm.
And so when that's it, when the publication is done, sometimes it's like a bit like, I don't know, like you do everything that make it work, even if it's a bit ugly on the engineering side, I would say.
Yeah, that's what exactly I'm facing with my current paper. It's like, you know what, I'm going to run a little bit of machine learning and then just try to write the paper, and that's about it.
Yeah.
For a different project, the reason why I wrote the code in a certain way is for every semester we get a new data set. So I just wanted the future analysts to be able to just plug in a new data set and be done with it.
Yeah.
Mm-hmm.
This is a difficult task. This is where it seems like for developing function like or tools that handle different kind of data sets. It's super hard because like the structure of the data can change, the dimensionality, everything can change. And yeah, all you deal with potential error, because you always have like error, like let's say either like yeah yeah, some, let's say, non R is doing a good, doing a good job with non any value, but like you have other kind of error like that. So yeah, this is yeah, this is difficult. And all your coworker are like are they like, how do they see R or the programming side? Because obviously here we are all into it. I mean, we think it's a useful tool and it's valuable for your times and like for the labs, everything. But does your coworker feel that? Or
They of course know about R and Python as like buzzwords, and we tend to be biology teachers, so we actually prefer R in most of our cases, just because the applications tend to be there, and a lot of the bioinformatics biostatisticians tend to use R these days.
Yeah,
at least the ones we come across.
Yeah. Python is a bit wild. Like two of the business analysts, my team, say like, "Oh, we'd like to go into Python." And as a data engineer, I was like, I don't want manage Python environment. And I feel like also like R, you get like, even if you just use base R, you are very loaded as tool to Python for data analysis. You have a lot of abstraction you need to add before doing data analysis.
I agree. Yes.
which can be. I mean, the other good part is like if you want to do other stuff, Python also have web development, no problem. Like I mean, no problem. Less this also down, but like yeah, as a data analyst, I think R, even Baz R, already have a lot of stuff going on. And if you just do tidyverse, which is super easy, yeah, I think it's a good selling point for like people, because like if they want to manage Python, they will need to manage Python environments and manage Python dependency and manage all of that. With R, it's super hard to have like dependency issue. Like I think I have once in last 3 years and something like that.
Mhm.
And it was mostly dependency of dependency. Like it's not like direct dependency, like it's so yeah, it's happened to me once. So
Yeah, I
yeah.
completely agree. My university, we're trying to set up a whole entire Jupyter hub for the whole campus. And
Oh,
as a teacher, I want to have a system that helps me automatically grade homework.
Mm.
The issue is that the software was made 3 years ago, and we've already run into so many dependency issues, and I admit I cannot fix that.
no, the bad way of fixing a Python dependency is like running everything into a virtual machine or a specific environment. It's kind of a bazooka, you know, like you have a trouble of dependency and then you bring back Docker, Conda, everything like to solve just a dependency issue. It's like you are, yeah, but R you have like way less problem, I feel, but yeah. So that's good, like people like evaluating that. And but do you think like they are building script? What are the use of it? Like, do you think like they are just my coworker are writing thousands and thousands of lines? You know? Or do you think like yeah? How do you think like you can like sell them being more doing their work more programmatically and using program like function or evading like even starting with custom function that they are recalled from source, then going to like Jim mentioned a package. What do you think will be like the good a good way?
I didn't have much more here, Jim.
Yeah, I don't know. I see a number of directions that teams can choose to go in. And yeah, I think there's a way in the Python community to achieve the same goals.
Oh yeah.
For sure, in our community, where CRAN has gotten is very useful and desirable on a number of topics. But I don't doubt that on the data engineering side, you know, the brute force, you know, moving data from place to place, that sort of thing, that there are other people that have built some pretty nice tools.
Oh yeah.
But I've never been limited by a language. I guess you know, I came into this with Fortran and C. So these other higher level abstraction languages are just beautiful. You know, they abstract so much away and make it so easy for teams to work together. And in fact, for me, you know, a real programming language has a compiler. All these other things that we call languages aren't really languages at all. They're you know, tools. They're really sweet, you know, interactive tools. And so I'm really enthusiastic about what I see, like in the geospatial space in R and what's accessible from the outside world. I've been okay with what I've seen from, like I mentioned, Spark and Databricks. That open source world has been useful in dealing with large data sets, as has been Arrow.
Yeah.
Project Arrow. That's been nice. Data table in some ways too. but I'm more enthusiastic about Arrow, to be honest. And then yeah, so we've not arrived at the final, what everybody's going to use, but I think in some ways we've got useful tools that we can solve problems we have today, or for the clients we have today.
Yeah. And do you think like because like the chapter was more like adapting like good programming practices?
Oh, yeah, good point. Yeah. That's fair. So what is good programming practice? Yeah, it gets us much closer, definitely, to what we're going to become, regardless of language. So somebody reading this in whatever Ruby or some other Julia, some other language,
trending Julia,
could probably take the same lessons and think in terms of the same standards. And it's certainly true, the functional programming and the sort of package development applies regardless of language environment, that we want to have something that stands up and stands the test of time, that's modifiable, that's verifiable, that's testable, all the things that were in this chapter.
Yeah, this is one difficult stuff with our users. That's because a lot of them, myself included, are not programmers by training. Like it's super like difficult to explain, for example, to a non-programmer, well, data type can matters, and like storing everything as a text will have a cost at one point. And yeah, like even like sometimes it's happened a lot in the geo world, like you have some floating precision issue, which especially with coordinate, which seems ridiculous, but like GeoJSON, for example, is text based, and it have like so floating precision. So when you do spatial operation with it, you can create like some slivers that's no one can see it because the precision is very small, but the computer see it and bug. I mean, bug it, stop it, because like it create like small non. So trying to explain that to the value of understanding a data type, data structures, to a non computer science main students, or that came from a business perspective, that want to do stuff down and want to use the tools. And it's nice for that, because like the data type is not very like strict about it, but the counter, especially in the spatial world I have seen, is like sometimes you have like issue because of the data type not defined, and then if they are not defined, the way it's stored is basically like the biggest common denominators. So sometimes you are not catching errors because like everything is a text. So and I have seen something like that, but
Also,
good.
Also in this geospatial arena, I'm briefly mentioned that for those of us who are just beginning on this, dealing with satellite data and relatively large data was kind of prohibitive at first, and finally, someone pointed out downsampling.
Yeah.
Going into the next chapter, looking at the statistical machine learning and spatial algorithms, I'm going to have to finally use parallel processing to see if I could run this code. And fortunately, at home, I do have multiple cores where I might be able to take advantage of the speed up. But that's just something that's going to be pretty exciting in the next week.
You know what my generation say? Like I'm considering old as a special analyst now. Is if data is too big, you should aggregate it. And basically, what S3 is like, S3 like the like the hexagon way of representing stuff. S3. Even the concept of the rasters. It's just like, how can we count stuff in like a cell, and instead of counting every point, can we go for density? And this is pretty powerful tool that was used before, like we had all this powerful stuff. And usually when I run into like some computing issue, I'm thinking, should I convert that to a raster and do just matrix operation? And a lot of times I feel like the precision is not worth it. So I should definitely, and that's what people like, all the smart people that use S3 indexes or geohash. I don't know. Do they explain the geohash here in this book? I'm not sure. Like, it's just you just encode as a string a location instead of using the location. You divide the globe by letters and numbers. I do not remember exactly, and then you can make distances by checking the difference in the string. Like, obviously, it's not perfect, but a lot of time you do not care to be like at the meta or whatever level. So you're perfectly fine with doing an aggregation and using a special indexes, like a B tree or whatever you use. But yeah, definitely like, and like, yeah, this is all, like you have also like, this is Roger Bivens. I think he will die on this hill. Like, he's basically like, I came from ecology and geography, so we use a lot of distance, like really, and he's just saying like you should just use neighborhood, and I think he's right. A lot of the time, it depends of what, a lot of the time we have like a very good result by just going through what is closest or the next neighborhood, which require way less computation than calculating a bunch of matrices of distances, which is way harder to do. I mean, not way harder, just stupid matrices, but the matrices is bigger. So yeah, I don't know. This is like the. So I think he's right, but you were like not sure about it, Jim. The distances versus neighborhood.
Oh no, I agree with you. I do, and maybe I'm trying to break myself of the Spark paradigm where you throw compute at it.
Yeah.
There was a talk this past year, and I forget the guy who delivered the talk, but it was so good about, it's possible in many cases also just to get a big virtual machine.
Yeah.
And to do just what you said, and just because you have a tool like Spark doesn't necessarily mean that that's the best one to use. And that's really shaken my thinking that in many cases, to get the answer that's meaningful, or that for the decision that needs to be made, that some of the older aggregations or simplifications actually get you what you need. Spark is an interesting way of doing compute, but staging everything to work that way. Oh man, and it takes a lot of effort to rewrite R or Python to actually stage through all the compute cores. And at the end of the day, you're almost better off not doing it, I guess is the argument. And I'm coming around to that camp. I guess there are other technologies. We mentioned Arrow, we mentioned
DBT,
DuckDB,
yeah.
or DuckDB. There are other technologies, lightweight technologies that get around this, and I think in the geospatial space, this is especially important. You mentioned rasters, and I think people who are a little smarter with their, say, computer science abstractions, that goes a long ways, and this chapter particularly gets to that.
Yeah. And yeah, to be fair, also, like if you are doing machine learning or like some kind, you will at one point need to run simulation.
Well,
and
yeah.
I think simulation at one point, you need compute. There's no secret.
Yeah, absolutely. And in fact, for real life problems, the Bayesian approach is a lot of validity for most real life problems, not just some, but most.
Yeah.
And you're absolutely right that some degree of simulation applies with known distributions and such, and absolutely. Well, and it's possible that the folks at Databricks or other, Spark will come up with means of accelerating that. But right now, there are other tools that seem to be smarter and better.
We'll see.
Yeah.
But yeah, if you start using this tool, like the computer science is way more in front, I will say. Like the need of computer of programming came way like faster, I think, more prevalent, because you are dealing with a lot of definitely more computer closer to the machine, at least. Anyway, think we're good. Do you have other topic like you want to bring from these chapters? Not all of them were on this chapter, but there is nothing like really like, I don't know, to say about it. One stuff that I can say about these chapters is like sometimes, it's good to because it's true. Like I guess also what the chapter wanted to show is like those algorithms are not magic. You can implement them by yourself if you need. And the way to implement yourself is not necessarily obvious, but you can do it. Like, and I'm still afraid if someone like asks me to like, I had that in the interview, like, do just like in R the like write code for like a Monte Carlo simulation, like just the Hamiltonian. Well, I managed to do something badly, but I'm, it's not perfect. So I think doing it helped me like demystify a bit them, and knowing like maybe if I can focus myself, I can write some of them by hand. Obviously, my implementation will be worse than a lot of them, but you can still do geometry with R and stuff like that. And you can, if you understand a bit of geometry, you can implement a lot of algorithms that are here. So I think this chapter also is here for that. It's like telling you, like, also if you have special case, special needs, you can do it, which is very powerful. Like you are not necessarily constrained by what you get by, let's say, like your package, or if you are not happy with something, you can implement it, copy paste code from others, learn from it, and progress on it. But I do not have too much about these chapters, like checking it, but if others have something, feel free.
No, but I do appreciate this conversation. I do. The reason I came to these R4DS book clubs is to learn more and to learn with other people.
Yeah, from different backgrounds.
Mhm.
From very different backgrounds. But no, I feel like the need of C now to understand a bit of it. But
in the Slack channels, Gus Lumpkin, or what his name is, he just posted his solutions to Advent of Code, and he uses a lot of RCPP.
Yeah, to be faster.
Mm-hmm.
I think like people want to. There is no good free book on RCPP, I think. I think because it's I think the only book on it is a paid one. Maybe there's one. I don't know. Do you know one, Jim?
No. And granted, coming from Fortran, this C is interesting, but yeah, Gus is doing some nice work. I agree. Absolutely. I'm interested in other sorts of R extensions, but the extensibility is amazing.
Extender, yes.
That there's ways to reach back through these other languages, through Rust, through Fortran, through C. Absolutely.
Yeah, a lot of R was in Fortran at the beginning, no?
In fact, and that was my coming in. Absolutely. That's how I came on with R, and some of the things that make sense for me is compiled from Fortran.
I don't know. In the geo world, they said like if you have an image, nothing beats Fortran, but I don't know if it's true.
Well, yeah, sure. Absolutely.
This is a saying. I have no idea why. Anyway, I think we're good. Yeah, except if you want to add something, I will type end. And Derek, you're gonna do the machine learning and the statistical learning. I think the difference in term is important.
Okay.
Next week. Yeah. And well, see you later. And yeah.
Yeah, next week. Yeah, have a great week.
Yeah,
And
likewise.
bye,
See you
bye
guys.
everyone.
See you next week. Bye-bye.